All right, class, example number 1 for the Chapter 7 outline has to do with degree days versus gas usage. So what this is saying is like on a 50 something, like a 52 degree day, we hit this point right here, which is about 1100 cubic feet of gas usage. So it's a relationship between how hot it is versus how much gas you're using. You're probably running your air conditioner. So as it gets hotter, you're using more gas. There's like a strong positive relationship here. You can draw that line right there. It's a strong positive relationship. And the first thing they want you to calculate is the slope. And remember, I gave you that equation for the slope. It's B1 equals R times SY over SX. And they'll give you the numbers like this right here, a summary of the numbers. And so you should just be able to plug in the numbers and get your slope. So the slope is equal to 0.9953 times that. There it is right there. See, they did it for us. And that is equal to 0.19. So the slope is equal to 0.19 for the first part. And now that I know the slope, so that is 0.19. What I'm going to do is find the y-intercept because I know everything else. I know y and x as well. I'm just missing this y-intercept right here. So to solve for y-intercept, you use the y-intercept formula, which means you subtract this part of it over. This is the key formula here. If you know that, you'll know everything. Minus that b1x over, and you get this. That the y-intercept is equal to the original y minus b1 times x. And that is this right here. 5.31 minus 0.19 times 22.31. So it's 1.07 equals the y-intercept. You won't have to calculate much like this, maybe like once on a test. And you'll have the numbers. It's just kind of, plug in the formula and get it. As long as you have the formula, you'll have the numbers. This shouldn't be a hard problem at all. So now we're going to write the equation. So the amount of gas that you use is equal to 1.07 plus 0.19 for every degree day. So what this equation is telling me is that every degree that you go up, the gas bill is going to go up by the amount of gas used is going to go up by 0.19. So we go up by 1 degree, we need 0.19 more cubic feet of gas on that. So, it's a positive relationship because it's plus, right? So it's positive relationship, and it's going up by 0.19 every time. So this is just like how fast it's going up based on the relationship between the two. All right. So the next thing they tell us to find is the correlation coefficient. And so the correlation coefficient is just your R value because they're going to tell it to you. And that is 0.9953. And then from the correlation coefficient, it's really easy to find the coefficient of determination. So the coefficient of determination. And the way you do that, the coefficient of determination is equal to R squared, which is this squared, 0.9953 squared. All right, so let's find that, 0.9953 squared. All right, so I'm going to use a calculator here and pull up my calculator. So 0.9953 squared, enter, 0.990622, so 0.99, well 0.991 we'll call it, 0.991, so that would be my correlation of my coefficient of determination. My correlation coefficient was 0.9953. So that means these are about 99% related. That R squared tells you what percentage is accounted for by the association of the variable of the correlation. So they're about 99% related, and that does make sense because as the temperature goes up, you're almost directly going to spend more on your bill, on your gas bill. And the last part they say is predict gas consumption for 40-degree days and 20-degree days. So predict for 40-degree day would be like this. We're going to use the formula that we have. So let's go to our formula. And our formula, remember, is just this one right here that we calculated. 1.07 plus 0.19 times degree days. And we're plugging in 40 for the degree day. So our predicted gas will be 1.07 plus 0.19 times 40, because it's a 40-degree day. And let's do that in the calculator. So let me pull up the calculator here real quick. So I get 1.07 plus, and I'm plugging in 40 for the degree days into the formula that I have. 0.19 times 40. And I get 8.67 as my answer. 8.67 for 40. So let's predict for a 20-degree day. And for a 20-degree day, I expect my bill to go down, right? This gas bill should go down. 1.07 plus 0.19 times 20. So you plug in 20 and see what you get. So let's see what we get on that. 1.07 plus 0.19 times 20. And I get 4.87. 4.87. So that would be my prediction on a 20-degree day. All right. And so the next part on your outline, it says find and interpret the residual. Find the residual for this point. So they give you a point. They say they measured it, and at 30 they got 6.4. So what we're going to do, so that's our x and y. So let's calculate that. So for 30 degrees, they're saying they got 6.4 when they did it. So let's plug it into this equation here and see what the difference is, right? So for gas, what we would expect for the gas is 1.07 plus 0.19 times 30. So this is what we actually expect to happen by our prediction. And that would be equal to, let's calculate it, 1.07 plus 0.19 times 30. And you get 6.77. 6.77. So that's our predicted gas was 6.77. And remember, your residual is equal to observed minus predicted. So that's another one of them formulas we talked about earlier. You probably need to write that down somewhere too on a formula sheet. So this was our observed, the one that we actually observed. And this is our, this 6.77 is our predicted. So our residual is equal to 6.4 minus 6.77, which would be equal to negative 0.37 if you were to subtract those. And that would be the answer for our residual. And that is the end of example number 1 in your Chapter 7 outline.